All right, y'all. So we are on lesson 7. This is page 20 of your notes packet. Today, what we're going to work on is solving quadratic equations. Remember, that's an equation with an x squared as the highest exponent. And we're going to solve today by graphing. So essentially, we're going to pop these equations into our calculator. We're going to graph them. We're going to find the x-intercepts, and those are going to be the solutions. So let's start by graphing this equation right here. F of x is equal to x squared plus 5x minus 7. Remember, my f of x I can just treat like a y. So y equals x squared plus 5x minus 7. If you grab your calculator, and type that in, y equals x squared plus 5x minus 7. Go ahead and hit graph. Again, if your zoom is all messed up, just hit zoom 6. Should take you to a standard zoom. Okay? So let's go ahead and zoom out so that we can see the entire graph. I can see the bottom is cut off here. So there's a couple different ways I can do that. If I want to be lazy about it or quick, I just go to zoom out, which would be 3. And then I need to hit my enter one more time and it'll zoom out, right? If I want to be real specific with it, I can go to zoom window, or actually it's zoom box. That's number 1. If I hit enter, now I can draw a box with my cursor that it'll zoom to the box region. So I get it to the top left of where I want my box. I hit enter, and now I start tracing down, all the way down until I get my vertex in there. And now I go right, and you can see the box start to open up. And if I hit enter like that, there I got a nice shot of my vertex and my x-intercepts. Okay. So let's talk about some stuff here. First of all, over here it says shape. Is it my parabola opening up or opening down? Nope, it's opening up. It's like a U, right? Opens up, that means it looks like this. Okay. Then it says the vertex. Is your vertex a maxima or a minima? Or a maximum or a minimum? In our case, we have our vertex is right here. Since our graph opens up, our vertex is the bottom point of our graph. That means we have a minimum, okay? And we can actually calculate this value in your calculator right here. Go to second calc. You're going to select number 4 for, well, let's see if it's a maximum or a minimum. Get a new calc up in here. So again, if here's my graph right here, I need to zoom out. Let me actually just adjust my window. Okay, now if I want to calculate my minimum, I go to second calc. Number 3 here is minimum. I'm going to select that. It asks me to be left bound. So I need to move my cursor to the left of that minimum. And then right bound means it needs to be to the right. Then I don't need to guess, I just hit enter. And right there, it's going to give me the coordinates of my minimum, which are -2.5 and 13 and negative 13.25. So I can go ahead and write that in here for my vertex for my minimum. Negative 2.5, comma, negative 13.25. Those are the coordinates of my minimum, my vertex. Everybody good on that? Okay, the next thing it asks for is this axis of symmetry. That is the line, the vertical line over which your parabola is symmetrical. And really all this is always just going to be this equation, x equals, and then whatever the x value of your vertex is, because that's like the middle point horizontally of your graph, right? So in this case, my equation is going to be x equals negative 2.5. All right, my calculator busted. Okay, we already went over how to find the zeros, right, which are the x-intercepts. Can you guys find those on there? We have a second calc. We're going to calculate the zeros, right? That the reason we call them zeros is because at that point my y value is 0. So I hit enter. Let's do the left one first. It means I need to come all the way over here and get to the left of that 0. And then I move to the right to get right bound, hit enter. My first 0 is at negative 6.14.
Negative 6 at 0.
Except for in this one, it's not exactly negative 6, is it?
Negative 6.14005.
Exactly. So sometimes they're not going to be whole numbers. Okay?
I think their big man is so strong. And their coach is big. What's height of that?
All right, so I got negative 6.14 for my first 0. And let's calculate our second one. Did anybody get it yet? What'd you get?
0.
You don't need to constantly press it. You can always just hold it.
Yeah, that doesn't work with this feature up here. Okay, so my second 0 is going to be 1.14. Okay, so there are my x-intercepts right there. By the way, those are the solutions to that equation. The next thing it asks for is a y-intercept. Here's how we do the y-intercept. We're going to go to second calc, and this time we're going to go to value. And what that's going to do is it's going to allow me to put in an x value, and it's going to calculate the corresponding y value for this function, right? What do I know about my x value at the y-intercept? At the y-intercept, the x value is always going to be equal to what?
0.
Good job, Sam. It's always going to be equal to 0 because I'm right here on my y-axis, right? So all I do to figure out the y-intercept is I go to second, calculate value. Are you with me?
Second, calculate.
Value. Should say in the bottom left of your screen, x equals, and it allows us to fill in. We're just going to pop a 0 in there. We're going to hit enter, and it gives me my y-intercept. What's my y-intercept? -7. Good job. So if I want to put in coordinate form, it's 0, -7, right? All right, cool. So let's go ahead and sketch a graph of that with all that information, and then we'll get to the next part after that. So just going to fill in this right here. My x-intercepts were a -6.14. X equals -6.14 and a 1.14. My y-intercept was a -7, but in coordinate form it would look like this, 0, -7. So let me go ahead and sketch this graph. Should look something like this. Got a parabola facing up, and I can label these points. So I can label my vertex, which is at this point, -2.5 and -13.25. Okay, I can label my x-intercepts, which are at -2.5 and then 0 for my y. And, oh, my bad, I messed this up. X-intercepts are at -6.14. And +1.14. All right, and those are the main things. This axis of symmetry, now we can visualize that. That's at this line, which is x equals -2.5. That would be this green line right here, that vertical line. And we can see how our parabola is symmetrical both sides of that, right? So our last two questions on here are the interval over which this is increasing and the interval over which it is decreasing. So that brings us back to our interval notation up here. Remember, we start on the left with the lowest number, comma, the highest number of the interval. And we have two types of brackets. We have the square bracket, which is inclusive, and we have the parentheses, that means it's exclusive. So the interval over which this graph is increasing, that is from my vertex going right, that is the place that as my x increases, my y increases, right? So that is the interval I'm going to describe here. I'm going to use parentheses on the left because I'm going to use the exclusive sign. And I'm going to start on with -2.5 is my lowest x value of that interval. And my highest x value, that's going to go all the way up to positive infinity. And I always use a parentheses with the infinity because I can't include that as a value. Cool. So that's the interval over which this thing is increasing from -2.5 as my x all the way up to infinity as my x. So the interval over which it's decreasing is going to be from -infinity for my x all the way up until it reaches -2.5. So that's going to look like this. Parentheses, -infinity, comma, 2.5. And it's a -2.5, again with the parentheses.